Alright, yeah, Unified Facility Criteria, UFC, Operational Maintenance and Petroleum Systems. Chapter 7, Full Storage Tanks, General information. The majority of the above-ground tanks, storage tanks used by the Air Force petroleum products are built accordingly. API standard welding steel tank for oil storage, API standard 65.3, Air Force standard design, see figure 7.1. 7.1 is an Air Force standard tank. New below ground horizontal cylinder tanks must be constructed in accordance with the UL 58 steel underground tanks for flammable combustible liquids. Conform to environmental requirements of Title 40 CFR 280 technical standards with corrective action requirements owners and operators under the storage tank. The current edition typical should be double-walled Type 2 tanks. Current criteria for the above-ground, below-ground bulk storage tanks storing aviation fuels requiring installation product recovery tank to remove the water tanks from the tanks. The product recovery tank should also be programmed installation of existing facilities with and without water draw-off systems. Figure 7.2 and 7.3 motorized pumps are used in new systems. When an electrical power source is already available and additional costs can be justified, hand-operated pumps must be used, and on all other installations, product recovery systems are not required on product product bulk storage tanks. Diesel heating fuels, however, that may be desirable to have such a system installed on a bulk MoGas storage tank. That the system should only install the above-ground bulk MoGas storage tanks facility with 20,000 barrels or larger. Operating instruction in the TL 3711. Alright, figure 7.2 is a water draw-off system. The water draw-off system. Alright, the tank bottom is below the stainless steel product return pipe, is with a slope changing to the ball valve, check valves, and return pump through a T increase where there's a T dry breaker on disconnecting outside the dike. Into the draw off water system over here. The diameter vent shut off the site glass with density ball, so you can check the site. Thread cap, lockable ball valve, and the diameter vent. The tank with cone bottom and the removed the top. The tank shell carbon steel. Socketed welded tank nozzle stainless steel. This is the wall right here. It's showing the next position. Welded to the drum. Alright, 7.2 types of tanks. 7.2.1 above ground floating roof. These types of tanks are generally used in the storage type lightweight volatile liquid jet fuels. The tank is designed to decrease vapor space over to the stored liquid. The problem of the rainfall melting snow accumulating with the top of the roof dock on the top of the old floating roof tank is improved by sloping the roof at the center sump. The sump is in connection with the hose, the multiple joint pipe extended through the fuel to the outside of the water draw-off valve. Because the valve must be closed and locked with unintended water contaminant remains the problem, wherefore the rainfall is heavy over shorted periods. Most floating roof tanks have aluminum fixed roofs installed over the open top where the accessible water contaminate of the fuel is possible. For maintenance requirements, possible responsibility paragraph 10.6.2. For all new construction of a cone roof tank will internal aluminum honeycomb with a floating pan. Military Handbook 1022A. 7.2.1.2 roof seals. The efficiency open time of the floating roof, the preventing evaporation hoses, looses in transit the precipitation, reducing the possibility of the rim fires, depending largely on the effectiveness of the seal, closing the space between the rim of the roof and the tank shell. If the seal does not prevent the escape of the vapors around with the seal ring evaporating will occur. The seal ring must fit the tank and shell and snugly the type of the seal. Generally used with the open top float roof tank and has continuous steel ring with the vertical flexures about 22 inches apart. Figure 7.4 is continuously gas-type waterproof synthetic rubber coated fabric closes with the space between the sealing ring in the rim of the roof. The sealing rim is supported and held firmly but gently against the tank shell by phonographic hangers. Because these hangers apply with a uniform outward radial pressures, each flexure in the sealing ring, they tend to keep the roof of the property centered in the tank. In the freezing weather, the seal must be kept from heat of ice. Moderate use of calcium chloride crystals is permitted to at the discretion of the basic corpse engineer. Sealing ring must remove the free and only the tank shell during the filling, as well as during the removal of the fuel from the tank. Open top floating roof seals also are used in the type of the shown in Figure 7.5. Seals are the out cone roof tanks that have been converted to the floating pan floater. Usually have the type of the rim shown as Figure 7.6 cone. The roof tanks built in the new standard equipped in the honeycomb aluminum pans. Dual pan to tank and seal is shown in Figure 7.7. 7.4 shows the floating pan on the weather seal fabric, the tank shell, the panographic hanger, the metal scaling ring, and the with a roof deck and rim floating roof, bottom roof deck, and the weight. The floating panel in detail, the welded shield, hang bar, current and seal envelopes, top deck rim and seal supporting rim, and resilient urethane foam, bottom deck bumper. Floating panel seal on the top, 7.7, the new standard tank seal. Secondary seal, tank shell, evaporated mounted primary seal, stainless self-drilling screw at the friction centers, steel thick channel at the TM as customers. Self-drilling screws or panel joints. Thick steel skirts, insulating material, panel joint connector, aluminum honeycomb floating, diameter steel bolt and a nut, a gauge of the steel plate, foam dam, coat before assembly, steel and angel. 7.2.13 automatic float gauge. Figure 7.8 and 7.9 showing the type of the gauge is used on the open top of the float ring roof tank. The gauge is actuated by the float end and well of the deck, and the float is connected with the gauge of the type of the stainless steel cable. By connecting the float to the cable, the turnbuckle, is possible to quick adjustment for the overhead reading, under reading length of the cable, and under reading of the shortening of the cable for overdoing. The tape is counterweighted by both the tape and the counterweight are enclosed in the weatherproof housing. The tape is read through a window. The gauge head uses the spring actuated storage heavy sheath to take up the tape instead of the counterweights. The tape is used and passed over a sprocket sheet having the register of the liquid level in the tank on the counter wheels. For the more accurate reading on one tank, the float panels of the tape is attached directly to the honeycomb pan. Note the design will not be read full fuel level below on the setting of the pan legs and not substitute of the automatic tank gauging. Automatic tank float gauge. Sheave, stainless steel tape, stainless steel cable, wind gird, pipe bracket, reading window, the counterweight and the drain from the stainless steel floatable roof with the gauge well and the liquid, so you get both readings in the tank shell. Automatic float gauge head. The float gauge head is winding of gears. Like they have mesh. It's a gauge, but like you got different gears. I could explain it, but you don't need to know all the parts. Automatic float gauge float pan. 90 shield elbow. Second required Class B with aluminum housing and non-Deller interpulley tank roof. Galvanized pipe nipple, large. 38 pipe nipple galvanized. 152 large. 300 number screwed half coupling gauge tape, the floating pan tank shell. Install the bracket, the galvanized pipe intermediate brackets, U-bolts, and the fitting on the center of the galvanized union, the galvanized pipe nipple, the center reading of the window, and above the tank bottom. So you got your gauge reading down here, centralized pipe with the galvanized union, and the float pan with the gauge tape where there's weighted by the line down to the gauge reading. Also taking the gauge of the floor, the weight of the taking the both consideration. Notice to the designer provide either the servo level gauge or the mechanical tape gauge based on the user requirements. 7214 cone roof tank with a floating aluminum honeycomb pan. The tank is designed with above ground storage to reduce the effects of the weather. The aluminum honeycomb pan lays directly on the fuel surface, eliminating any trapped vapor above the fuel surface. 2 rim seals prevent vapors from escaping the atmosphere. The tank is acquired by Air Force Standards Design. 7215 horizontal cylindrical. New design criteria limits to the tank size to the maximum of 1,015, 416 liters, 40,000 gallons. Is equipped with a direct reading gauge. Provides with a manual gauging to determine the tank's fuel level. Following NFPA 30, NFPA 30A, UL 142 steel above ground tanks, flammable combustion liquids. Figure 7.1 shows the horizontal cylindrical tank. Figure 7.1 horizontal cylindrical tape. And 1 from the left going to the right, and then to the bottom to the left or right. You have your clean out connection, tank vent and manhole gauge of the hatch, fill line, liquid level gauge, deep well pipe, pump, check valve, check valve, plug valve, line strainer, central figure pump. So your central figure line strainer, check valve, plug valve. The plug valve's up here, and now you have the 8 check valve, deep well pump, 6 liquid level gauge, 5 fill line gauge, hatch, manhole, tank vent, and cleaning out connection. Alright, 7216 self-diking evaluated tanks. The self-diking vaulted tanks. Removing the underground storage tanks is creating the new market of the above-ground tanks that do not need dikes and can be located next to the buildings. We are more attractive than standard tanks. Are more attractive than standard tanks. These tanks range in size from 940 to 54,240 or 250 to 1,200 gallons. Tanks used in the application require secondary containment must be UL listed. Secondary contaminant tanks will be steel liner, steel outer tanks that can provide with the interstitial containment of the pressure is stable, verifiable. If the application requires a fire-rated tank, the 2-hour fire rating must exceed all NFPA 30 and NFPA 30A requirements for fire-resisting tanks. It must also meet the requirements for the Uniform Code Article 52 Fuel Dispensing Station and UFC Article Flammable Custom liquids provide with a minimum 2-hour fire rating of the UFC Appendix Standard A2F and UL 2085 standard of the project. Above ground tanks for flammable combustible liquids. Tanks and jet fuels must have stainless steel inner tank of the C Mill Handbook 1022 for the additional requirements. Many popular manufacturers, even so, of the GSA listed, do not meet the above the requirements of verily performance before purchasing. Rectangular. When the building separation is not issued where the dikes can be constructed, rectangular type of the tank may be acceptable for the National Fire Protection Agency 30, 30A, and 31 standard installation of oil burning equipment. The UL 142 when secondary contaminant is not required, such as small heating of the tanks and exposed and aggregated with the concrete in case tank may be desired, such as the tank low profile attractive provided with low level secondary contamination. 722 ground tanks may be constructed with to meet the requirements in the NFPA 30, 30A, and 31. Additional follow the Title 40R CFR 280 of the State Environmental Laws. Horizontal cylindrical new tapes and should be factored construction of Type 2 double-walled tanks complying with the UL 58 criteria. Slopes tank 1 towards the water drain and Military Handbook 1022A for the requirements of the tanks. On ground vertical cut and cover, the tanks are primarily used for the overseas location of the design, typically conform to the United States Air Force and Europe. NATO standard. This type is not typical constructed on us. Good. Maintenance of storage tanks. All above ground storage tanks are carefully selected and maintained to prevent the fuel evaporation. General maintenance requirements are determined to be tank components. Tank surfaces only touch the paint is done by the LFM personnel. Painting the entire tank is usually done under the contract outside the petroleum fuel. Storage tank is painted to comply with the applicable portions of the Navy Guide Specification Section 09971. Coating of the steel structure automatic atmospheric surface of the Navy and Air Force. The interior is painted in applicable proportion to the Navy Guide specifications 09973. Lining of the wielding steel petroleum fuel tanks. The projected life in the interior coating of the system is over 30 years. Do not recoat the entire tank unless the coating has failed, because the weathering aesthetics of the exterior tank needs to be repainted more frequently than the interior. Applying or maintaining non-slip coating of the tape of the roof, walkways, and ladder rungs where the surfaces become slippery when wet. Interior surface maintenance, including inspection for sludge deposit corrosion, is on schedule recurrent for the basis according to the requirements of paragraph 10.6, with the cleaning of the repair as required. Cleaning the interior surface will follow the procedure Chapter 12 if cleaned, and for the house, the type of cleaning for the procedure given in Chapter 11 will apply. Carefully inspect the underside of the tank roof for signs of weakness and corrosion due to the oxygen and vapor. Perform a touch up on the paint as required. Seals above ground on the top of the float tank are subject to the deterioration atmospheric condition. The following maintenance services are recommended and performed as intervals outlined. Paragraph 1062. The brush, the fabric claims and bolts of the non-ferrous wire brush and the removed rust and scale. Replace deteriorated defective bolts, tighten the loose of the bolt clamp, thoroughly clean the fabric surface with the cleaning substance. Apply one or more of the coats with the white elastometric coating compatible with neoprene into the fabricated with the clamps and bolts. Below ground tank maintenance inspection is limited to those portions of the tank lines that are exposed to the inside of the manhole vaults and pits. Inspect those exposed surfaces periodically for corrosion and chips. Repaint the necessary surface maintenance, including the inspection of the sludge deposited corrosion. Must be on schedule recurring the basis in accordance with the requirements of paragraph 10.6, including the interior surface following the procedure given in Chapter 11. Operating storage tank with the below-grade access ways must be on one manhole enlarged the 36-inch diameter and extended with at least 2,003 millimeters above the grade, including later rungs and the access way the extended of the floor. For the quality region for the requirement of the slotted gauge for the pipe of the operating storage tank has been deleted from the Air Force standard design. The portion of the gauge pipe inside the tank must be removed from the tank shell as soon as possible. Newer tanks may have the slotted stainless steel sitting, well, engaging and sample wells. Perform touch-up painting is required as using applicable portion of the Navy Guide specification section 09973. Surface preparation is the key to the job. 7.4 Pressure vacuum vents. Description and use of the pressure vacuum vents are required on all tanks except for open-top floating cargo floating pan tanks with capacity of 2,000 gallons or more stored pit products with a flash point below the 37°C Celsius 98 degrees Fahrenheit. Check the local environmental requirements set. The requirement may extend to the fuels of the higher flash point and may require the vapor recovery processing. The vents the vents maintaining the work pressure in the tank with safety limits of the pressure vacuum, preventing the normal breathing, reducing loss of the fuel evaporation with the pressure vacuum vents are used. The flame arrestor is not permitted when we're already installed with the pressure vacuum vents. The flames arrestor should be removed, except for the USAFE base, where it is a national Northern American Treaty Organization or host nation mandatory requirement of the flame arrestor to be used in the vent lines. The flame arrestor must be non-freeze type, and figure 713 shows simple below ground tank valve. Tank vent. The shaft weighted arm weight with a snuffer chain plan. Alright, your handle nuts, your A-frame cover, your weight, your cover gasket, your guide post, your hood and screen over the cover basket of the guide post of the seated ring of the screen from the pressure vault to the vacuum pallet, the vertical end housing, bank assembly side plate and cover plate in section. Section 13 below ground tank venting with the 1142 pressure vacuum vents must kept in perfect working order to prevent sticking or subjecting the tank and collapsing bursting conditions. 7421 in freezing weather operation personnel required of the TO 3711 to check the tank vacuum pressure vents for the freedom of the movement and intake of the output. Poppet valves. Pressure vacuum vent valve pallets should be maintained in intervals as described in paragraph 10.7. Clean the seating surface of the pallet's valve seat carefully with suitable cleaning. Inspecting seating surface for damage or undue wear. When replaced pallets, make sure that they move freely in the guides and the seating of the surface contain evenly and tightly. Inspecting the protective screen and at pressure vacuum ports, remove the bird and the wasp net, open the valve of the metal-to-metal seating. It may be necessary because of the corrosion to regrind the seating surface of the pallet's valve seats or the maintaining tightness using an extra fine regrinding compound or a light, even oscillating motion of the grind each of the pallet onto its respective valve seat. On the valves with new non-metallic pallet seats insert, it may be necessary to replace inserts carefully clean, groove in, install the new insert, making sure it's fit properly. Alright, 7.5 Diking. General information. Each above ground petroleum tank having a capacity of 661 gallons must be either surrounded by the dike enclosed by the containment structure and designed to direct spill and to be impounded area. Most Air Force tanks are surrounded by a dike. The following NFPA 30 with the capacity of the dike enclosure, except for the NFPA, refers to the volumetric capacity of the fuel tank of the tanks to tank instead of adding the volume of the 5-year, 1-hour duration storm, 1 foot freeboard, whichever is greater. The standard Air Force dike for a large vertical tank is constructed on Earth with at least the 76 millimeters or 3-inch reinforced concrete paving on the top and the slopes. See Military Handbook 1022A. Proper jointment placement is in which the fuel restraint and joint sealer is in slope and is in critical design construction element. The dike floor is typically crushed with the stone within concrete working ring surrounded with a tank ring wall. And if a concrete floor is desired to be justified on the economical basis, use the liner is placed beneath the dike and on the spray on the coating is acceptable when the concrete floor is installed. Is also installed. Individual tankers larger than 10,000 barrels should be included in the individual dikes. Several small tanks less than 10,000 barrels each may enclose in one dike up into the total capacity of 1,500 barrels. When 2 or more tanks are on one dike, subdivided in using the 18-inch tall immediate dike, slope dike that carried the drainage to the dike of the drain. A swing line and lock drain valve will be used, and depending on the weather requirements, a swing line that may be raised or lowered in the interior of the dike area will be closed. We use on the cold weather problem areas. A drain with locking gate valve will be used in the freezing conditions do not present the problem. This valve must stay in closed and low position until the dike is drained. The valve is staffed during the drain operation to prevent the possible discharge of fuel pollutions in sanitary systems or the bodies of the water. Water from the dike will be discharged and is required governing environmental regulations. All pipe in the dike must be fire resistant, such as steels and stainless, and avoided with aluminum with the dike area. 752 alternate dike construction. Earth dikes basins around the fuel storage tanks require continuous maintenance to prevent erosion and elimination vegetation. Some installation have applied with non-selective soil sterilizer to the top inside the surface of the dike and elimination vegetation. Surfaces are treated with at least 76 millimeters of crushed rock, pit, or run gravel. To hold the rock in place, geotextile sprayed on the asphalt can be used to inspect the air dikes, earth dikes according to the requirements outlined in paragraph 10.8.1.